Okay, this is 4.1 Polynomials. This is part 4, and this is actually going to be more around factoring than just about anything else. We're going to talk about how to factor using groupings, and I want to show a trick that we can use to help solve some of our problems that are larger than our standard, square root or our quadratic. So here I have I'm going to try and factor this out so that I have, by a group, I'm going to have some solutions here. Now this, I can see I've got a negative 9 and a positive 18. Okay, so that looks like if I factor a 9 out of there, I'm going to have a group, right? That will factor. And then I have this where I can take out an x squared out of everywhere and wind up with something that's going to be an x minus 2. So it looks like this is going to work really well when I factor. I'm going to factor this section first, and then I'm going to take these guys and do those next. All right, so the first one I'm going to take, and I'm going to do my x squared. That's what I'm factoring out of here. That leaves an x and a minus 2. All right, and then on this one, I'm going to factor out the negative 9, and then I'm going to have an x. Because I'm factoring out the negative, I'm going to have an x minus 2. All right, so now I've got this term works for both of these. So that's good. That's what we want. We want to have our term of x minus 2. And then I have this piece left over. I've got this x squared minus 9. Now if you stop and think, this is going to be one of those forms that factors nicely for us. It's one of those terms that I recommended that you kind of like memorize or be aware of. And in fact, this is what we did. This is how we got our complex conjugate to work out. Okay, so this is going to be our x plus 3 and our x minus 3. Right? So now this has been factored out nicely. So this whole thing is going to become my answer. I'm going to have an x minus 3. All right, so that is, this whole thing right here is my answer for a factored group. All right. Now, what happens if we have something bigger than that, or if it's kind of set up so that we have this quasi-quadratic thing? Okay, and when I say that, I mean this, the exponent on this one is twice this one, and it only has 3 terms. Okay, it's going to have the whatever x to the 2 times whatever our variable is, 2n, and then we're going to have our x to the n, and then we have our whatever our constant is. So I'm going to say we want to pull this apart, and when you're looking at it, something to the 4th, that's really intimidating, and then we have all of these other things going on. It's like, all right, well, this gets too intimidating overall. Well, there's a trick here that we can use, and I'm actually going to change my color up here so that I can, let's go with that. I'm going to say let m equal x squared. All right, and when I do that, now I can say I have this squared, right? This is going to be my m squared now. So I'm going to have m squared plus 4m minus 45. Okay, so now we have a quadratic, and we know how to solve those. This actually factors really nicely. It's going to factor to our m plus, and it's going to have an m minus. I know the larger number is going to be a positive, and if you take a look, my factors here are going to be 9 and 5. So my positive is going to be the 9, and my negative is going to be the 5. Okay, So we've gotten this far. This is, we're making progress here. Okay. Now we're going to plug our original x squared back in. We're going to replace our m back to our x squared. So this is going to become an x squared plus 9. And then I'm going to have an x squared minus 5. All right. So when we do this, we're going to have to solve this. We're going to set that all equal to 0. So I'm going to have x squared plus 9 equals 0, which becomes x squared equals negative 9. And then here I'm going to have my x squared minus 5 equals 0. And now I'm going to move that to the other side. So I'm going to have x squared equals 5. All right. So far, so good. Well, we don't want x squared. We want our x, right? So we're going to take this one more step. All right. We're going to take this to one more step. And that is, we're going to go back here. We're going to take the square root of both sides here. So here I'm going to have my square root. Whoops. Helps if I actually. There we go. I'm going to have my square root of x squared is going to equal the square root of negative 9. We're going to break that apart into its composite, so we're going to have an I in there somewhere. We already know that because there's a negative under there. In this case, I'm going to take my x squared and take the square root of that, and then I'm going to have that, I'm going to take the square root of my 5. All right? So in this case, I wind up with my x, taking the square root of the square, that gets me my original x, and then I'm going to have, remember, this is my square root of negative 1 and the square root of 9 multiplied together. So I'm going to have a 3i here as a solution. All right? And then here, I have my square, and my square root is going to be just an x. And then I don't have anything that I can break this down to. This is as good as it gets. So I'm going to say this is going to be my plus and minus the square root of 5, right? And then this, we would have a plus and minus as well, potentially. All right, so that is a key or a trick in factoring. Hopefully you find it useful. I am going to end this now, and hopefully all of these are really helpful.